Welcome. Today's topic is Learning Vector Quantization LVQ. LVQ is a competitive learning network with supervised learning, which means it has labels with it. It's a process of classifying the patterns where each output unit represents a class. Initially, the set of training patterns with known classification along with the initial distribution is given as input to the network. After completing the training process, LVQ will classify the output and give the output class. The architecture of LVQ is as follows. It's similar to the architecture of KSOM. It has n number of input units and m number of output units. The layers are fully connected, which means each neuron is connected to every other neuron with having weights. The weights are W11, WI1, like how we number the weights usually. The parameters used in the LVQ are X are the training vectors x1 up to xn, T is the class for the training vector x, Wj is the weight vector for all the output jth unit, and Cj is the class associated with the output unit. C is the final class and T is the target class. So the training algorithm initialize the reference vectors from the given set of the training vectors. First, m number of training vectors are assigned as weight vectors and remaining vectors are used for training the network. Assign the initial weight and classify randomly. Apply the k-means clustering algorithm. Initialize the vector learning rate alpha. Calculate the Euclidean distance. Find the winning neuron. And if t equal to c, the weight updation formula is Wj new equal to Wj old plus alpha into x minus Wj old. If the target is not equal to the obtained class, then we have a minus in this place. Reduce the learning rate alpha. The formula is alpha of t plus 1 equal to 0.5 into alpha of t. So we reduce it by half. Test the stopping condition. If it satisfies, complete the iterations. If not, change the learning rate still to half the number and continue the process. So initialize the weights and the learning rate randomly. For each input vector x, find the winning neuron by Euclidean distance similar to SOM if t equal to c. If the target is equal to the actual class, then the formula has a plus. If the target is not equal to c, the formula has a minus here, and the learning rate alpha changes to 0.5 into alpha of t. If alpha reduces to a very negligible value, then start from the beginning. If not, stop. Thank you.